Okay, so today's work we are looking at what chemical equations mean. And we started to kind of pull this apart before break where we talked about reactants go on the left side of the arrow and products go on the right side of the arrow. But that's kind of as far as we went. So today we are going to talk about how we can interpret a chemical equation going a little bit further than just reactants and products. So first, we want to pull out of here our reactants and our products, and then we're going to talk about what's a coefficient, a subscript, and what actually happens in our reaction, as well as what are these little symbols in parentheses. Okay, so let's get started here. So our first one with a blank says A plus BC. So I've got my A and BC here. So these would be my reactants. Looks like I have an element and a compound. And then there's a 2 bolded in front of the 2A. So whenever you see a large number in front of another, like here or even on the product side here, that is called a coefficient. And when we count up how many of a particular atom we have, which we will be doing today, you will apply a coefficient to everything that follows it in a particular substance. So in this substance it's just A, but in this one we have A and C. So it's kind of like distribution. Again, here this would be B and C. Whenever you have a coefficient in the front, you multiply it to each atom inside of that compound or element, whatever the molecule is. Next we have the arrow, and this separates our reaction from what we see before and after it occurs. And so we can say that this, typically we'll say this means it yields. But it means that it forms or produces. Those are other words that you might hear when you are working with reactions. And this is not one of the blanks, but these plus signs here are telling us that it's like and, right? So you're mixing them together and they are produced together. So on the reactant side, when you see that and, that you're saying, we're mixing these two things together to react. Afterward, this is what is produced, and it's just telling you there's another substance. Just like we had A plus BC on the left side, now we've got B2 plus AC. These are our products. Now notice, when I'm writing the reactants and the products, I am not including coefficients, because the coefficients are just telling me how many of each, kind of like a recipe. So here, this is kind of like a recipe. But when I'm actually listing out the products, those are my actual ingredients. So when I'm making cookies, I don't call sugar 2 cups of sugar when I'm just talking about them. I call it sugar, right? So that's why I'm not including the coefficients. However, I do use this little number in there, which leads us to our next one. The little number is bolded here. Whenever there's a tiny number in a formula, remember that is telling us how many of that particular atom it is next to. This is called a subscript. Subscript. Okay. And we only have one atom that this pertains to. It does not distribute around. It's just whatever it is directly to the right of, at that bottom right of the element. So this is telling us there's 2 of the element B, and I include it in my product or my reactant of what the actual substance is, because that is part of its identity. So those little subscripts, we don't change them. They're part of the ingredient, if you will. It's not the quantity of how many there are. That comes from the actual identity of the substance. Remember back to ionic compounds, You get the subscripts from doing the crisscross method, so that's not really something that changes based on how many, it's just what it is. And then lastly, in our chemical equations, you will see parentheses with S, L, G, or AQ. These are telling us the state of matter of the substance in the reaction. So are we mixing solid, liquid, or gas version of that substance? That's what these stand for. So S is solid, L is liquid, G is gas, and then AQ is not the same as liquid, but it does make you think of water, because like aqua, right? And you'd be right thinking about water because AQ stands for aqueous, which means it's dissolved in water. So it's a solid powder, if you will, that is dissolved into water. So it will usually be a clear liquid if it is aqueous with that ionic compound dissolved in water. So there's our interpretation guide, kind of a key here to help us do this example and count our atoms. So our example says, label the parts of the chemical equation, then indicate the state of matter of each substance in the reaction. So we've got on the left side here a big box. These are our reactants. We've got copper 3 sulfate and sodium. Practicing that naming, don't forget the naming rules. Then on our right side we have the products, sodium sulfate and copper. So our reactants yield our products, that's our arrow. And then lastly we just need to indicate the state of matter. So AQ, that means it's aqueous. S, we got solid sodium. So what this is telling us is that we have copper 3 sulfate dissolved in water, probably in a test tube or beaker, and then we have solid sodium. Can help you maybe visualize this a little bit better. We've got a beaker with liquid, and we've got solid sodium that's going to be mixed together, so put it in there. Here's our reactant happening, and then our product. After we give this some time, then it's obviously still in the cup because we started it in a cup. Now, the solid will be in the cup because we have the reaction going on in the cup. So what we'll see is a precipitate form, and our precipitate will be the copper solid at the end. Okay, so that's what we see. This is our products of the sodium sulfate is in the liquid, and then the copper is collecting on the bottom. So there's our reaction of what it might actually look like if we were to observe it. Count the atoms of each element in the chemical equation. So let's use our knowledge of subscripts and coefficients to count them. So first we have copper. Copper is here on our reactant side, and it has a subscript of 2. And that applies only to the copper with no coefficient, so we are set. Now, sulfate has parentheses around it. So whenever you have parentheses, this is one thing we did not talk about earlier, this is indicating multiplication similar to a coefficient. So now our subscript applies to everything inside of those parentheses. This is the only time that a subscript applies to both. So that would be 3 sulfurs, and then 3 times 4 oxygens, 12. And then lastly, sodium, it has a coefficient of 6, but that only applies here. And remember, when there's no subscript, it's an implied 1. Okay. If it had a 2, then it would be 6 times 2. Okay. We'll see that on the product side here with a coefficient and a subscript at work together. Let's start again with copper. It's got a coefficient of 2, so it's just, not 1. That would be 2. Sulfur is here. It has no subscript and no parentheses, so it is only going to be affected by this distribution of the coefficient. So I have 3 sulfurs. Oxygen, I have a 4 subscript and a 3 coefficient. So 3 times 4 is 12. And sodium, I have a subscript of 2 and a coefficient of 3. 3 times 2 is 6. You will notice that our reactants and our products have the same amounts of each atom. And this is how we balance an equation. This one's already balanced. That will be our focus next week. Balancing an equation is helpful and necessary because it shows us how the equation follows the law of conservation of mass. And remember, that means all of the atoms have to be present in equal amounts on both sides, which we are showing here by counting up each atom and showing that they are the same amount. Even though they're in different bonds and different compounds on the reactant side and the product side, the actual amount of atoms is consistent, which tells us it's following the law of conservation of mass. So that will be helpful moving forward. I will teach you how to actually balance them yourselves next week. So our practice for today, you are looking at some chemical equations and then identifying those parts that we've just discussed. And for the ones that are listed in parentheses, you'll just circle whatever applies and then fill in the blanks.